Happy Wednesday, everyone. Welcome to another Lunch and Learn. My name is Kevin Holbrook. I'm one of the technical staff here at CAD Dimensions. If you haven't attended a Lunch and Learn previously, just give you a little idea of what our approach is for these sessions. We kind of pick topics that maybe are a little more obscure, maybe not covered very well in the training manual, and we just break down and dissect different areas of the software. More of a training-like session, not really a sales session. So hopefully you're in the right spot today. Today we're going to talk about, at least the topic is features you forget about. And I picked a few of them out of the pull-down menus under features that are useful but maybe not used all that often. One of the things that makes it easy to forget about is a lot of these tools they've removed from the command manager or a lot of the toolbars by default, so you may not see them or get access to them very easily without looking for them. A couple of housekeeping issues before we get going specifically on what we're going to cover today. If you have any questions during the session, please post them in the question section of the GoToWebinar window. At the end, I will circle back and cover any questions that we do have on the particular features. Now, I have a bunch of them pulled aside today. Our agenda is going to cover these items: Freeform, Deform, Indent, Flex, Cavity, Join, Split, Thicken, and Cut with Surface. All of these, again, were just a little bit more obscure, some used more than others, however. I did originally have Dome in on the description. I didn't think the tool was working as well as it should be at this point, so it wasn't worth showing. So the way I'm approaching this is for each of the features, I just pulled out of the help file a description of what SolidWorks says the feature does, and then we'll go in and take a look with several examples of how to use it. I think all of these features contain, a majority of them contain a lot of different options that will provide you with different results. Very much like, let's say a sweep that has all these different options that are going to give you different shapes and curvature and information. So we certainly can't cover every little option. If you have questions about anything in particular, I'll certainly go through them, but I'll try to be as comprehensive as possible. Now, the first one, I'm covering kind of the best first. I think Freeform is one of those tools that could be utilized a lot more in the software if we just knew where it fits. Freeform feature works on faces of a solid or surfaces. It allows you to modify the face interactively with like push-pull control, and it allows me to very precisely control the direction that I'm pushing and pulling, the location on the surface I'm pushing and pulling, if I have symmetry. All of those things kind of play a role. So let's just take a look. I'll start with a very simple example. Four-sided surface. The command is under Insert Features. You're looking for Freeform. You're going to select the surface that you want to freeform modify. Now, what you're going to end up with is all of the edges are going to give you a continuity selection. In this particular model, when we deal with continuity, we're not really dealing with faces of a solid model that are connecting to it, so it's not as much important, although I will show you how we could use this particular tool. Each of these are just pull-down menus with options, and I'll show you what some of those options do. What we want to do is provide the software with curves that we're going to locate points on, and those points are what we're going to move and modify. What you're seeing now is just a mesh that's placed over the top of the surface, and that's really only there to give you an idea of the quality of your surface, how distorted that surface is. If I go to the bottom of the freeform tree, I can actually increase the mesh density so I can see that a little bit better. So the first thing I'm going to do, and I'll just show you a generic example here, is I can go ahead and add some curves. Now, this function in SolidWorks works very different than what we're used to. These are all buttons that you toggle on and toggle off. So when I say add curves, I then go to the graphics area, and hopefully this comes across in the GoToMeeting. You can see the green line within the surface that I'm on. As I make a selection, it places that green line as a curve or a location that we're going to push and pull. Now, once I've created the curves, I can go ahead and either flip direction and add curves the other direction. So let me just show that. I can flip and add some horizontal curves in here if I'd like. Now, once I have all of my curves, I need to add points to those curves. Well, the first thing I want to do is turn off the add curves function. You have to kind of toggle it as a button here. And then you go down to your control points. Adding control points on a curve is you telling the software where you're going to push-pull. And I'm just going to do some very basic stuff here. I'm going to go to the two curves here and maybe put 1 point in the middle of each of the others. You add only the points that you deem necessary. Okay. Once you're done adding points, you turn it off. Okay. Now that we've got our points, the best way to see those points is to grab the curve. And you can see there are several points at the intersection of the two curves that I can use, as well as the ones I've placed. By selecting those points, I'm presented with an axis. Now that axis or triad is used for the push-pull drag. Now its orientation by default is the same orientation as the global axis. You can see let's see if I can give if I look to the top here, it's matching the global axis. What you may want to do in some cases is change the orientation of the triad. I can make it normal to that surface. By making it normal to that surface, when I push-pull, I'm going to get a different result. Once I get the axis the way I want, I just grab the axis of the triad and I start to drag it, and that will deform the surface. Notice the mesh allows me to see a little bit more about the quality of what I've done. Now, any of the points on the curve, you can modify the triad, you can modify the direction of the pull, and then you'll have these arrows at the end of the curve that allow you to change the tangency in the curvature leading in to the changes that you've done. So you can see how you can take a surface and really get pretty nifty with it. But let's go a little bit further with this same surface here. We have options at the top of the Freeform dialog where we can create symmetry in certain directions. In other words, anything I change on one side will change on the other side automatically. Okay, I can turn these on in both directions if I like. Doing the same thing, adding my curves. I can add a curve on the center line. I can now add points. And now anything that I do will be symmetric on this part. Okay? So we can do symmetry in both directions, add as many curves as we need. Now, let's take this a little further. You'll notice how as I'm dragging this out, that the boundaries of the surface are maintaining their location. They're staying intact, not moving in this case. If you want the curves to actually be able to move from their original orientation, you can make them movable. Okay, making a curve movable is going to allow you to grab the point on that curve and will actually be able to move the edge. Okay, I can pull that edge away and deform essentially what I already have. Okay, and these are some tangency for that. And I'm just going to change that up just a little bit differently here so you can kind of see that movable a little bit easier. Let me make this symmetric. So, when we look at modifying a moving edge like this, you can see I can pull that edge right away. This is a great example of creating, maybe a more freeform shape. Get this on the surface here if I can get to it. There it is. Add some points. You think about what it takes to create a surface like this using existing techniques. It takes some time. I could do something like that very, very quickly with Freeform. Okay, so Freeform, in its very basic sense, and just a simple surface, allows you a lot of different control, but very predictable control. When you get into working on surface models, it can be helpful to utilize things like existing sketches to modify the surface to match that. Here's the same kind of technique. I want to freeform this. I want symmetry in direction 1. I want to add curves. Now notice when I add curves, if you're following along just trying to do this, I'm adding the curve to the symmetry plane, and you kind of got to move your mouse around a little bit till it highlights so it knows you're adding the curve to that. When you add your points, you're also adding them on the curve at the symmetry plane. So I'm going to add a few here just to make sure I have what I want. And now I can go ahead and start to modify and change those. I'm going to use the surface orientation for my direction. Now another thing that I like, and if you've used any spline tools in SolidWorks, they've made some changes over the years as far as how to control the curvature of the spline. And you can see if I'm pulling these points, other things are moving. It's a little bit harder to match what you're trying to do. However, in splines we have the ability to use the control polygon, and that control option is also in Freeform. So I want to use the control polygon in this case, and now I can really control where that curvature is by using the polygon. And I can match the geometry as it exists, okay, and get the shape that I want. And I get a real nice surface here. Okay, I get a shape that would have taken me quite a bit of time with quite a few curves to create. Now there's one other subtle piece to Freeform that I think is really nice to work with here. So I have kind of a mocked up faucet in this case, but the reality of it is the faucet, this side surface comes down and it swoops and becomes tangent with this face here. One of the functions in Freeform that allows me to do that is this option under control points, snap to geometry. So I'm going to use this surface. I'm going to tell the software that this is a movable edge, this is a movable edge, and this is also a movable edge. Now when I do that, all I have to do is start to grab the curves of the edges that I told were movable, and I'm going to grab all these points here. But I have the ability, when I move this point, to snap it to geometry. See how I'm snapping that in there? Okay, I can snap to geometry. I then have the tangency point. I can snap to the corner here, the tangency, and do the same for the backside. Now the result of this, because I'm able to snap to the geometry, look at the nice surface it was able to create in there. Okay, so you can, and I guess for me it's a little bit hard to quantify when you can use it, and it will take some trial and error. And these are nice surfaces too. If I come in here and want to fillet this thing, I mean this will fillet. This is good good fillet surfaces. Okay, so this isn't going to be an issue getting things to be useful after freeforming it. It is, and this one fails, but I think it's due to the size. These are nice surfaces. Okay, another good way to kind of check that is use your zebra stripes, or take a look at the continuity of the surface that way. So Freeform is the first tool. I think it's kind of lost in the shuffle a little bit. It's there, but maybe we need to look at how we can utilize it if you're creating any Freeform parts. Now this one's even harder for me to figure out where it might fit. Deform allows me to modify complex shapes globally without worrying about sketches, constraints, all the other things. Now the modification is the part that makes it a little bit harder for me to understand. Let me start in SolidWorks here and just take an older basic example here that I found from an older What's New. If I wanted to do a deform, it's under Insert Features, Deform. I have three ways of deforming. I'll show you all three here for a moment. We're going to start with curve to curve. This is where we say, okay, here's the existing curve. Here's what I want the part to look like. Okay. Now, under the region, if I don't specify only a face that I'm going to deform, it's going to use the entire body of the part. And I can start to tell the software, here are the edges that I don't want moved, or I don't want deformed. So it's going to take the existing flat curve and try to bend or modify the part so that it matches the curvature that you have listed. Now, as far as predictability, it's not like you put any numbers to this. You're really using the controls of the curves that you provide, as well as some shape options we have at the bottom here. The shape options really dictate whether the weighting of the shape is more towards the fixed edges or the moving edges. And if I go more towards the fixed, you'll watch that the shape will change a little bit more. It has more of a tangent feel to it as it comes up and around. I can also change the stiffness, or how easily it's modified. And you can see as I change this, it changes the shape. And you can see I even get like a little hump in the center there because we're making it much more stiff in certain locations. The result of this is a deformed shape that maybe we can work with here. Now I probably should have probably made these edges immovable, and that would have cleared up that issue, but it gives you a little bit more in terms of predictability. It sounds like the audio just came back. I'm not sure how long we were out. If you could just raise your hand in the GoToWebinar window if you have audio currently. Okay, sounds like we have audio. If I'm behind in the audio and you need to see something again, please just post it in the question section. We can kind of go back to it there. So deform is quite interesting. Let me go back in and let's use like a point deform now. Let's do something completely different. So with a point deform, we tell it the point on the model we're trying to deform. It's just an arbitrary point. It's a location on the model itself. What body is it that we're trying to deform? Okay. I'm sorry, I've got to get my deform point. Once you get the deform point, we can tell it the distance that we're going to deform. Now this is kind of weird. You see how that? It's just like dragging that edge up there. Let me clear that. On top of that, we can specify the radius of the deform. So what I kind of equate this to is almost like it's taking a sphere and it's smashing it against that point to deform it predictably by a radius. Now, on top of that, you have the same kind of controls where you can say, hey, don't deform this face or this face, keep this intact. You can control which faces get deformed. Okay, so that's the point to point. Now, to probably illustrate what this is doing better, I can use something they call the surface push. Surface push, first you give it a direction of the push. Again, there's the arrow for the direction. You then give it the shape that you're pushing the model with. Now, there's some default shapes already in here, like ellipses and polygons and rectangles. I'm going to use a sphere in this case. Or you can select another body that you're pushing it with. Now, once I use the sphere, you can see the preview of the sphere itself. And in the graphics area, I can specify the radius of it and the position of it. So I can actually move this sphere. Now, this seems to, I think, give you a little more predictable results. It's not necessarily the center of the sphere that's actually making the deformation, but it's the entire sphere's influence on those surfaces. And again, I can tell the software, you know, the location of the sphere and move it side to side. You can see it even deforms it radially in this direction as well. Now, the quality of the surfaces that you end up with in this tool, there's an accuracy, shape accuracy slider, and you know, dragging it obviously further to the right is going to give you a little bit more accurate solution and something maybe a little bit more predictable. Now, how do we use deform in something that's maybe a little more real life on a model here? I have a couple examples, maybe not perfect examples, but you know, here's an example of deform to create the neck of this bottle. So if I edit the feature on this one, we're using a curve-to-curve deform. So what we have up here is just a sketch on what we want the neck of the bottle to look like. And then we have the initial diameter of the cylinder that we used. We tell the software we're going to fix the bottom edge, and it's able to curve that in to meet the top of the bottle. So where we would typically have to use a loft to do that, the nice thing about this curve to curve is that it's actually offset. Well, actually this one isn't. Yeah, it might be a little bit offset. So this curve isn't necessarily center line to the axis here, but it's a nice way of kind of moving edges. Now, when I say moving edges, now here's maybe a little better example of what I'm talking about. If I look at the outside shape of this particular part, this was all done using deform. So let me just edit the feature here to get a sense. What I did is I took the existing edges of a part and I said that's my initial curve. And then I offset it and said, you know what, I really want that surface to kind of have a draft or an angle to it, have more curvature. Now, I don't want to go back through all the features and figure out how to make that happen. That could take forever. So I use a curve to curve, and then I fixed all the edges where it meets the top features. So I said, basically, the only thing it can modify is all the outside edges. Okay, and then the end result, as you'll see as it works through processing, it creates 145 new faces on a model that might have 50 or 100 features in a tree. Okay, gives you the ability to modify existing. I encourage you, if you go into the help, they have some very good examples of, you know, very complex models where you're looking at just a very simple area where you just want to tweak it a little bit, where you want to move a model edge. And that's where deform would come into play, where you take an existing model edge and you say, okay, now deform it out to this curve. You know, instead of going back to the original guide curves or the original features, you can just modify an existing piece of geometry. In this case, you can see what I ended up with. You know, a nice little curve shape all the way around, created by the software. Back to one other thing with this I want to show. Let's go to my original deform. Let's say this one here. Now, with deform, it's very similar to lofting. I can actually right-click in the Deform tool and show the connection lines. Now, connection lines are how the initial curve connects to the previous curve. You can see that I have this, what I equate to a lofted connector here. And I can actually add connectors in here to control how things meet up. These are all editable and movable to change the shape and how it transitions from one curve to the other. Now, there certainly is a lot in here relative to this. One other thing that you'll read about in the help that I didn't have an example that was good enough, but if you're moving an edge or a model edge to another edge that happens to be a surface that has some tangency to it, you can ensure that as it curves it, it can maintain the tangency to other surfaces. So you can really get some control to make sure that the resulting surfaces are something that's useful to you. Okay. So deform, I encourage you to kind of take a look at that. The indent command, used to create an offset pocket or protrusion feature in a target body. Okay, let's take a look at that. All right. Now this is an example you may have seen in the past. Again, I pulled some of this from older What's New presentations that they've had. So we want to edit a part inside the assembly, and you can see that the toothbrush body fits into the base here. When we invoke the command for indent, there's a few options here. But first thing we have to specify is the target body, the body that we're going to indent. And the way I describe this is it's like taking, the target body is a piece of Play-Doh and you're smashing some other part into it. You're creating an indentation, except it goes a little bit further with this tool. We can tell the software that we want to remove this part from this target body. So basically cutting away. But here's where it differs than a cut, in that I can specify a thickness of the surfaces that get created around that. So I can have all these resulting surfaces be 1/10 of an inch thick. I can also create an offset so that it is offset from the original model by some distance. So in other words, this edge of the toothbrush here, or the surface, it won't start the indent for 1/10 of an inch from there. Now I do have options in here like cutting the model instead of indenting it or pushing it into the Play-Doh. It actually just does like a cavity or a Boolean like we're used to in some of the combined commands and cavity commands that we're used to in SolidWorks. But in this case, what we just ended up doing is creating a indentation feature in the other part. Now, what's really nice about this feature is that it's associative to this other model. So if I were to go in and modify, maybe add a fillet to the bottom surface of this model, okay, when I go back to that assembly and I go ahead and hide my part here, you can see that the fillet now exists there as well. So the indent, anytime you have parts that fit together or something has to sit in a pocket, it's a great way to create that. Now there's a couple other things with indent that I just kind of want to show. It's a little bit different in how we utilize it, but there's the ability to specify what you want to remove or what you want to keep. Now when you specify what you want to keep, it gets a little bit hard because it doesn't know necessarily what direction you're trying to push the toothbrush into the part. So as you can see, the yellow area, it's trying to push in that direction. Let me show my toothbrush back here. So make sure we've got that handle. Now with the keep selections, you actually can specify the areas that you want to keep. And now I'll use this bottom as an example here. When I select this fillet surface, it sees that it's intersected by this pocket here. And as soon as I make the pick, it says, okay, you want this area in here. Now I can go ahead and pick a second area if I need to, maybe in a second side. The key here is you have to pick a unique face in each quadrant. But the result is very similar in that we've created, in this case, an indent in those areas, but the sides that I didn't indent become just cutaways. Okay? So indent, pretty neat. Let's keep going here. Flex. I think this is probably, of all the commands I'm going to introduce today, it's probably number 2 as far as predictability. Anytime you need to deform a model intuitively, bend it, twist it, taper it, stretch it, we have customers using this very, very successfully. Okay? It does just that, bend, twist, taper, and stretch. Now if I look at how we do this, get out of here. Let's start with something very simple. The command is under Insert Features Flex. You have the option for all 4, bend, twist, taper, and stretch, and you pick the body that you're going to bend, twist, taper, or stretch. Now the real key and predictability to this has to do with something they call trim planes and the axis coming off those trim planes. Now the trim planes is the area in which we're going to perform, in this case, the bend. Now those trim planes can be moved. I can drag a trim plane from one end to the other. In here I can specify exactly how many degrees I want to bend, twist, taper, or stretch. Okay. Now you can also grab the planes themselves to bend and twist. You can adjust the axis that we're bending around. I can just grab this axis and kind of tweak it that way. If I want to bend in a different way, I can certainly do that. Let's see. Another thing that you're able to do, let me just reset everything here, is you can control exactly the area in which you're going to flex. So I may come in here with the trim plane, and then I can right-click on the triad and actually move it. Now remember, the trim planes is the area in which you're bending, twisting, tapering, or stretching. So if I move the triad to, in this case, plane 1, I've now locked the triad there, so all my curvature is going to start from there. So watch as I start to bend and twist this thing. Nothing to the left of that axis bends. Okay? So I get a very, very predictable movement. It's only between here and here. Now I could have moved this trim plane in even further. Now the bend is only between this section. Okay, and again, I can control what that happens to be. So none of these surfaces get modified. Now in the end, I have something predictable that I can work with. Okay. Now another example that I found useful with bend, twist, taper, and stretch. This is a very crude example, I admit that. But there was at one point, we got approached by a tire manufacturer that said, hey, how would you draw up a tire with tread and show the tire? I mean, doing this as a revolve feature when you have tread patterns that are kind of unique is kind of tough. Well, this may be a case where you could use the flex command, because I can tell the software to flex this model 360 degrees. By flexing it 360 degrees, I've essentially was able to cut in the tread pattern and fold up, almost fold up a tire. Okay, to create a tire in SolidWorks. And I admit the tread is very crude. I just threw together an example here. So maybe another example here. Let's look at the other options within the flex command. We have twist. So if I wanted to twist something, very similar. I control the planes, the area in which I'm trying to twist. I control where it starts with the triad. So maybe I move the triad, in this case, to plane 2. And I can control the number of degrees that we're twisting. So in this case, it's a rectangular shape that I'm twisting. Maybe I want to show what a machine tool. I'm mocking up a number of flutes on a machine tool here. Okay, and again, you're controlling the planes and the area on which this occurs. Another thing that's kind of nice is you can actually flex a flex. So I can come in here and say, you know what, take this thing and flex this. I want to bend it now. And I just grab my plane and I can take that shape and bend it even further. Again, it looks like it's more of a freeform shape, but the reality of it is I'm bending it by a particular value. I'm saying this is the radius of the bend. So, if you're doing any kind of bent steel work or anything like that where you just need to create a bend and you don't need a loft or anything like that, you can use the flex tool to help you with that. Okay, another nice tool in SolidWorks. Cavity command. This one kind of went to the wayside when they created the combine command in multi-body solids. But at one point in time, when we created molds without the multi-bodies, we use a cavity to create a void in a solid model that we can then utilize parts to cut away that information. Now if I go back to the SolidWorks for a moment here, let's look at this one here. So I'm going to kind of take you through a couple different ways. Let's say this was a vacuum formed packaging example, or so you're trying to design that. I'm in the assembly to use this tool. I have a part called the small bottle, and I have a solid model for the area around it. What I would need to do, first off, is to edit the one component so I have access to my features. Cavity is listed in there. Now, design components, it already knows what it's trying to create a cavity in. That's the part you're editing. But design components are the components you're trying to remove from that solid block. What's nice is I can actually scale that automatically in here. So I want to scale about the component, let's say the component centroid, the center of mass of the component. I want to scale that up by 3%, and I'm essentially creating a void using the cavity command inside an assembly. Okay. Now, mold inserts used to be created this way. So I'm just going to show you how we used to create molds because it was quite interesting at one point. I'm going to just turn off the scaling here on this particular model, exit out. I want to actually apply the scale to the model itself. So this is something that's part of the mold tools. You can scale it by a certain percentage. It will increase the model size. Now when you get to the assembly, it creates the cavity. Now you have essentially two parts inside the assembly. Now to create the other insert, I want to make sure I don't want to scale. Still creating an offset. Anyhow, what we do in the assembly to create the other half is we can insert a component, a new part. We take the existing mold insert, we convert the edges, we extrude that up to some height. Okay, and now we just use the cavity command to remove both the bottle and the bottom half of the base, okay, from the two. And if I want to scale it, I could do that. And in the end, if I hide this, I've created the other half of the mold as well. So this is how molds used to be done in SolidWorks, but the cavity command is still there. I guess what I've used it for in the past is any kind, let's say tooling, where you need to create a place for a part to fit where there's kind of a cutout. You can utilize the geometry of the part and create a cavity of it. It's kind of like the indent, isn't it? It creates a void in the area, but you do it inside the assembly level. So cavity, it's there. Maybe you haven't used it in a while. So let's keep moving on. We're getting close on time here. There's a join command. I don't think in the 14 years I've been doing this I've ever been asked to join parts together, but I wanted to give you a sense of it's still there. Let's see. Join is kind of unique in that it requires to have a situation where maybe you've designed two parts separately and now you want to join them together into a single part. So to kind of use this tool, you have to have both parts in the assembly. And in this case, I want to insert a new part. Okay, I'm going to insert a new part on the bottom face. It gets a name. I can call this full knob or whatever. Full knob here. Now that I'm editing the part, I'll have access to the command titled join. Okay, join requires you to pick the parts you want to join. If you want the parts hidden, if there's a gap between them, can you force the surface contact? It will essentially build a bridge between them. Now, if these parts are interfering, it actually eliminates the faces where they're interfering. So it's kind of nice in that sense. If you've built two parts that maybe don't connect properly. But the result is a part inside the assembly that's all one. So you'll notice if I go to the full knob here, it actually creates a featured join with an external reference to these two parts. So if I were to go and make a change to these two parts, the join part will come with it. But now I have a part that I can detail and work with separately. Okay, maybe a little bit unique tool. Split. I think this is also one of the better tools that's not utilized. Split is the ability to divide a part into multiple bodies. Okay, these bodies can become separate parts later on or just separate bodies within that. This is typically used when you have two parts that need to stay the same size, need to have some continuity between how they fit together. So it allows you to create them as one to start with and then split them apart. My example that I have today, again, is a little bit crude, but let's say we had some sort of base to a piece of equipment or something like that. We're going to put electronics, maybe a keyboard on this thing. So what I've done is I've just created, a hollowed out part. And in reality, this is going to be two parts that snap fit together. In order to do that, we can use the split command. okay, and a plane that intersects the model to cut the part in two. Now, when I get into split, it just asks me for a plane or surface to cut the geometry with, because you can use a surface as well. When you hit cut part, it actually shows you how many different bodies that you can create using this. So each of these bodies can be named right here on the fly. So I can come in here and say this is top. Okay, notice what I'm doing when I click in that field. It's asking me to save it as a part. So I'll call that top. I'll call this bottom. Okay. Now I can specify maybe where I want the origin to be within the model. I can give it a location. I can copy custom properties from one part to the other. I can tell it what template we're going to use. And I can go ahead and specify. Now it's just telling me I have different units in my template than my original part. But you can see what I've done is I've made an assembly with multiple bodies in it. But remember, I created two parts from this. Now, one thing that we can do here is just to right-click on the split and say, you know what, create an assembly. You know, I can tell it, okay, what is that assembly name? Save it somewhere. And that's kind of goofy. It was a little bit off here. But it will take both parts and bring them in the assembly. What I might have to do here is just float this part and mate it up. But it keeps the two parts together. Now here's the real key to this, is when I go back to the original part and I roll back before the split, let's say I wanted to modify the fillet here. We're going to make some adjustments. Let's go back and maybe tweak the sketch. I want to tweak the angle on this thing. Maybe we're going to pull it back a little ways. I make all these adjustments, roll forward on the split, and this should, if done correctly, work its way all the way through the process. Not really sure why this is bouncing around, but you can see how that fits in. So split is a nice way of breaking things up into multiple parts, essentially to keep them accurate as far as how they fit together. I think that's really the best use of split. This one's very simple to show. It's a command called thicken, is not under insert features, but the ability to thicken surfaces. You can cut thicken them or boss thicken them, which is kind of interesting. All right, so I think I'm just going to take the bottle example I threw that on here. So if we go to our bottle, I did a thicken on the bottle. So let me take you through my process here for a moment. So the first thing I did is I did a split line. If you're not sure how to do a split line, I just sketched an ellipse. I went to Insert, Curve, Split Line, and I split the surface of the bottle. Maybe I'm trying to create an area that I need a label on the bottle. And then I use the Surface Offset command. So I take that new surface where I just split, and I say offset it by 0. Now what that does, it creates, let me hide my body here, creates just a simple surface. Okay. Now's where the thicken command comes into play. You can find it under Insert Boss Base Thicken or Cut Thicken. Okay, the thicken command in this case, I pick the surface that I created, the direction I want to thicken it, and the actual thickness itself, and it creates that nice little cutout within the part. Okay, if I wanted to boss base thicken something, I can just grab two surfaces, do the same thing. Insert a surface offset, offset it by 0, okay, and then do a boss base thicken, Take that surface offset. Maybe I want to give it 1 millimeter more on the outside, and I create new geometry. Okay? Utilize what you've already done to make modifications. I mean, sometimes you try to go back to the original sketches, original features, and you tend to get raveled up in all the sketches and geometry that you've just created. Well, this will help you make that a little bit easier. The last one, very simple, cut with surface. It's the ability to almost do what the split did, where I gave it a plane, I told it to cut the part. But this time we're actually cutting away material and removing it permanently. So if I go with cut with surface here, this is just a simple surface that I created that intersects the model. You're going to find it under Insert, Cut with Surface. You pick the surface you want to cut with, and the arrow determines the direction that we're going to cut on. So which side of the surface are we removing the material? That's all there is to it. When I accept it, it will actually remove that solid geometry. All I have to do is hide the surface body, and I can see the resulting feature. Again, when you look at some of the things that you have to do to create this geometry, sometimes it's easier to create a nice little surface that I've deformed and got the shape that I need, and then using that surface to chop the model up. So these are just a few of the features in SolidWorks that I think are, I will say, slightly ignored, but maybe not necessarily in the arsenal all the time. I recommend that, if you have any more questions on them, you can certainly ping me, ask any of those specific questions. But I kind of recommend just reacquainting yourself with what's there and what the possibilities are, because you never know when you're going to run into that geometry that you really need something different to get the job done. Now, I do have a few questions listed here. One looks to be related to Freeform. Can you add the curves or point at a specific dimension? No, you cannot add the curves or point at a specific dimension. If you know exactly where you need that, you can, most likely what I would do is just put a point at that location, and you can move your curve, and looking relative to it, you can just about pick exactly on it. But you can't give an exact dimension to the curves. That was something that was asked real early on, and they never really added that to the software. Can you use a negative number with Indent 2? I'm not sure where that would fit. A negative number. So something smaller than the indented part is what I'm assuming. Now, if that's the case, you cannot put an indented number. I do know that. But in a case like that where the indented shape is smaller than the tool that you're using, you may be able to just scale the tool using the scale feature. That might be one way. Yeah, I'd have to look at what kind of geometry you're trying to create with that. But negative numbers do not work. Oh, to leave material for hand fitting. Yeah, negative number does not work. So I hope everyone enjoyed the session today. This will be recorded and put on our YouTube channel. As always, we'll have a couple of these a month, so we look forward to seeing you soon. If you have any more questions, post them and we'll try to answer them. Thank you. If not, have a great day.